Okay, here we are, Unit 2, Lesson 5. We have been spending several days now, or a couple of days, looking at graphing a quadratic relation and trying to find some patterns to help us make those graphs. So at the top here, I have come up with a summary of the patterns you should have been observing in the last few classes when you've been doing your graphing. Basically, every quadratic relation can be written as simple as y equals x squared, or there can be numbers added to it. Those numbers added in 3 special spots. 1, 2, and 3. And depending on which spot the number is in, that will change what happens to the graph. So every quadratic relation starts as a basic parabola with its vertex at 0, 0, y equals x squared. After that, when you insert numbers, certain things happen depending on where the number is. So for example, a, if you have a number in front of the x squared, 2 things will happen. You will either stretch or shrink. If the number is bigger than 1 or smaller than -1, so if it's not a fraction, we say that the graph stretches or stretches vertically. So it gets skinnier. If you have a fraction in front of the x squared, we say that it's a vertical shrink. That means that it gets wider. So if there's a fraction in front of the x squared, the graph will get wider, also known as a vertical shrink. If there is a number that's not a fraction in front of the x squared, the parabola will get narrower. We call that a vertical stretch. The second thing we look for with the number in front of the x squared is that number negative? If the number is negative, then it flips upside down. We say that is a reflection over the x-axis. So this is some proper terminology that we're going to use to describe our graphs. When there's a number added or subtracted inside of the bracket and squared, it's called a horizontal translation because it moves the graph across right or left. And it's special because it's always opposite what you think. A positive will move the graph to the left, and a negative will move the graph to the right. And lastly, the number at the end. If you add or subtract a number at the end, it's called a vertical translation. And that's because it moves the parabola up or down, exactly what you think. If you're plus a number, it moves it up that many. If it's minus a number, it moves it down that many. So when we notice these patterns, we can do 2 things. 1, we can use this terminology to describe what is happening to the graph. So for example, use transformations to describe how the graph of the second function compares to the first. So if I start with x squared and I end up with bracket x minus 5 squared plus 2, I think of my pattern. Y equals a x minus h squared plus k. And I see that the 5 is in the h spot and the 2 is in the k spot. And I think of my patterns. H is a horizontal translation. So the 5 moves it across, and it's always opposite what you think. So if it's minus 5, it's going to move left. Sorry, if it's minus 5, it's going to move right 5. And the k number moves it up or down. Exactly what you think. So if it's plus 2, then it's going to move it up 2. So if I want to describe that, I would say that y equals x minus 5 squared plus 2 has a horizontal translation of 5 units to the right. And a vertical translation of 2 units up. So when I ask you to describe how the graph of a function compares to the first or the original or the parent function on a test, those are the terms I'm going to be looking for. To get a level 4, to get a perfect mark, you need to talk about horizontal translations, vertical translations, and which direction they're going, as well as vertical stretches or shrinks, or if it reflects over the x-axis. So if I look at the last one here, and I think about my pattern, y equals ax minus h squared plus k. This time, there's no h. There's an a number, and there's a k number. And so I know the k number is a vertical translation. So that's what I'm going to start with. It's easy. Y equals a half, x squared plus 3 is translated vertically up 3 units. And then I got to decide what the half does. The a value, the half, can do a couple of things. If it's negative, it's a reflection, or it flips it upside down. So the half is positive, so it's not going to be a reflection. Then I have to decide, does it make it narrower or wider? Does it stretch it or shrink it? If it's a fraction, it will shrink it, make the graph wider. So we say, and it has a vertical shrink by a factor of 2. Sorry, not 2, that's silly. By a factor of 1/2. The number in front is 1/2. All right, so that's one thing we do with our proper terminology. We can explain with the proper words what is happening to the graph. In addition, with the patterns we've been working on, we can take and use the patterns to graph by showing a series of steps to show what each number does. So if I think of my pattern, there's my pattern. I have a -1 for A, a 2 for H, and a 3 for K. So I know a couple of things. I know that my graph, A tells me that my graph, because it's negative, is going to flip upside down. So if I think of my original graph, my very basic x squared, we're going to do a series of steps. We're going to start with the basic one first, and then we will build on what each number does. So my basic graph is x squared, and I'm not sure we've talked about this before, but along the way in some of the videos I know they've talked about how to get the parabola shape. And basically, you're going to go over 1, up 1, and over 1, up 1, and then over 1, up 3. All the odd numbers. Up 1, up 3, up 5. And we get our parabola shape. And there's our very basic x squared. And because of the negative in front, the negative flips it upside down. So I take my very basic x squared and flip it upside down. Instead of going up 1, I go down 1. Instead of going up 3, I go down 3. And over 1 and down 5. So instead of following the same pattern, the step pattern of the odd numbers, over 1, up 1, over 1, up 3, over 1, up 5, the negative in front of the x squared means that it goes down the odd numbers instead of up. So that's my second step. My second step showed what the negative did to the x squared. My third step is the -2 or the -2 inside the bracket. That's my h. The h tells me that it moves across, opposite what I think. So if it's a -2, I'm actually going to go to the positive numbers. So I'm going to take my green shape and I'm going to move it to the right 2. So I'm going to take that whole shape and move it over 2. So the vertex is over at 2. The first point down is over 2. Second point down is over 2. And I just literally move each point over 2 units. And I can get my shape. And so now I've built up my graph, 2x minus 2 squared. So I have the negative because it's opening down, and then I've moved it over 2. So I've used the -2. And our last thing is the 3 at the end. The 3 at the end is going to make the whole graph translate up vertically by 3. So I'm literally going to do that. Take each point and move it up 3. And so I'm not always going to draw on those arrows. I'm just doing that to show you my thinking process. And there we go. So we took our negative, and we used our -2 and moved it over, and we used our +3 and moved it up. And that's how you graph using a series of transformations. You start with the basic shape, and you move the graph what each number does. So let's look at B. So our B, think of our A does, our H, and our K. And I'm always going to start with the basic x squared. So it's 0, 0, over 1, up 1, 1, up 1, over 1, up 3, up 3, 1, up 1, 2, 3, 4, 5. It'll fit. There we go. So there's x squared. And then we're going to transform it based on the equation. So this time the A number is a fraction. It's a half. It's positive as well. So since it's positive, it will stay opening up. The half, however, will change my steps. The steps will not go up as quickly. Instead of stepping 1, 3, 5, the odd numbers, my steps will be half as big because there's a half in front of the x squared. So I multiply each step by a half. So now I'm going to have the same vertex, but instead of going over 1, up 1, I'm going to go over 1, up a half, and over 1, up a half, and over 1, up 1.5, and over 1, up 2.5, and thus making my parabola wider, a vertical shrink. So I have used the 1/2 x squared. Next in my equation is the +3. So +3 is my h, and my h moves it across, opposite what you think. So because it's +3, I'm actually going to go to -3. And I'm going to move all my points over 3. And once I move them all over 3, join them up. And there's my parabola moved over 3. So I've used my half and I've used my +3 to make the graph. Last number is the -2. So -2 is my k number, and my k number moves it up or down exactly what I think. So I'm going to take all my points and move them down 2. So I start in the center, come down 2. Down 2. And I join them up with a nice smooth curve, and there is the finished product. I've taken that crazy looking equation and I've graphed each number, each step, and come up with the end result. So that's graphing using a series of transformations. So one other thing I want to point out, when we're graphing like this, the equation is always written in vertex form. And it's called vertex form, if you haven't picked this up from another video, because the vertex is in the equation. The vertex is the highest or the lowest point. So there's my final graph. There's my vertex. Over 2, up 3, 2 and 3. And there's my 2 and 3 in the equation. So it's a vertex form because you can read the vertex from the equation. Okay, so you should now be able to sketch on your own using a series of steps and describe what your graph would look like. So you should be working on those questions. Good luck.